Hello class. This lecture we're going to talk about database programming. So this is going to be a simple overview of SQL, databases in general, and then a little client-server architecture and stuff like that to better understand how we access these databases and other entities from our application. So here are the objectives you can read through on your own. The main ones that I would focus on are being able to describe the hardware components of a typical multi-user system, explain how a table in a relational database is organized, and then describe the use of these SQL statements, which I'll cover in my demonstration. We'll talk about throughout this lecture as well. Okay. So this slide's pretty important because this shows a little bit on how things interact with a database server. So when I say things, because it is more generic, as you can see, you just have random clients out here that are connected to this database server via a network. So this could be the machine that you're developing on right here that connects to the database server so you can test. This could be a client out here that your application might sit on, so it could be like a web server or an application server that other people can access to test your program, so like a quality assurance environment or an environment prior to production or something like that. So as you can see, multiple clients can interact with the same database server. So multiple people can be selecting from the database or inserting into the database or updating the database. So those are all concerns that you must deal with when you're writing these types of applications. So the hardware components of a client-server system, you can see the clients are the PCs or workstations of the system. So these are the things that typically connect to the thing that's serving your data or your requests, whatever the case may be. And the server is the computer that stores the files and databases of the system and provides services to the clients. So, for example, if you had an application, let's see if I can draw here. If you had an application A, and maybe this is this could be a website or something like that, or the machine that you're developing on. And then that reaches out to a service here. We can call this a service. Apparently these are only straight lines. And that service then, remember the three parts of a three-tiered computer program, then we have our database out here. Okay? So each one of these can sit on a different server, and typically do in a three-tiered architecture. So if we have here, we have the database. This would be a client, and this would be a server in this architecture. And this also could be a client because it reaches out to this database server. So you can see it all depends on the frame of reference when we're talking about what is a client and what is a server. Well, this is a server because it serves up information back to this service. So whenever your application wants to get a product from your database, well, it has to call the server, and it says, hey, I want to get this product or this gaming system or whatever product that I'm trying to get from your database, and then it says, okay, let me go get that from the database for you. So then this becomes a client and then reaches out to the database, and the database serves up the information back to the server, this service here, and then the service becomes a client or becomes a server and passes information back to the client that is your system or your website or whatever is trying to get the information from it. Oh, sorry about that. I don't know what I just did. Let's exit out of this drawing. Okay. So in a simple client-server system, the server is typically a high-powered PC that communicates, so it usually has a pretty strong processor and a lot of RAM. That way it can have multiple requests at one time, and it can serve up all of those requests at one time. Here's kind of what I was showing down here in this diagram, just with a little prettier pictures. So the client, which could be an application software data access API, which essentially is a service, it might send SQL queries to the SQL Server database, process those queries, and return results back to the calling server. So to manage, usually it runs a network operating system such as Windows Server 2012. Typically, database servers run something called Microsoft SQL Server for their server software. And a client software can really be anything. Typically, it's a data access API, or API stands for Application Programming Interface. It says the newest data access API is ADO.NET 4.5. The book is a little old, so don't worry too much about that nugget of information. Okay, so the SQL interface, or SQL, stands for Structured Query Language. It's a language to be able to do all of the basic CRUD operations on a database. So when I talk about CRUD operations, we're talking about C, R, U, and D. So if anybody ever mentions CRUD to you, those are basic database operations. You want to be able to create records in a database. It is not easy to type and write. So here we're creating records in a database. We're reading records out of a database. Create, read, and then we're updating records in a database. Maybe since it's so difficult to use a mouse, I'll just kind of abbreviate that. And then the D, we're deleting records from a database. So all things that we want to be able to do in SQL, and I'll go ahead and show those in the demonstration portion after this video. So that's what CRUD stands for. Let's go to the next slide. Maybe. So here's a table in SQL Server, or this looks like it might have been taken from Visual Studio. Typically you have a primary key, which is going to be the key to get the information out of the database. It should be unique, that way it can only grab one record. Then you can have a description, or whatever that you want to, however you want to describe your information. Here's another column called description, which is a string or a varchar, which are just variable characters. We have unit prices, which is a decimal of some sort, and then on-hand quantity, which looks like it's an integer. So again, we can do all of the same things we can do in C# and SQL Server. They have all different types of variables. The main difference is it offers the ability for tables to have relationships as well, which is important. So a table is organized with tables. It's just much like an Excel or an Access spreadsheet. You have databases that use tables, so you can have multiple databases grabbing from multiple tables. Most tables contain a primary key that uniquely identifies each row in a table, so you must have a primary key, but if you're not using a primary key, you can have a composite key, which is essentially multiple columns in the table which make up your primary key. So here's two related tables. This is an invoice here. I think here's the main invoice table. Yeah, this is the main invoice table. So this could be a receipt, like you went to Kroger and you spent $216 at Kroger here. Here's how much you spent in sales tax, shipping if Kroger shipped, So you can just call this an Amazon receipt. So here's your invoice total after product total plus sales tax plus shipping. Here's how much you actually spent on Amazon. Maybe they're having a Prime Day, so you went ahead and spent $240. So down here, we can see that our invoice ID is 46, so maybe they have multiple items on their invoice. So you bought 2 or 3 things on Amazon. Here's the first thing you bought with this product code, and here's how much it cost. Here's how many you ordered, and the total. And then here's the second thing you ordered with the price and the total. So as you can see, one record goes here, and then you have another table with multiple records. These are usually called line items. So if you have multiple line items on a receipt, that's usually shown in your secondary relational table down here. And they correspond to each other with this invoice ID, and the ID here is the primary key, and the invoice ID here is the foreign key. So this, if you're trying to get all of the invoice and the line items from a particular invoice, you would say where the invoice ID equals 46, and it knows that these two are married to one another. So here it shows the foreign key, the foreign key table, and then it also shows a one-to-many relationship, which is the relationship that other table had that we just shown, because one invoice ID could have many records in it in the other table because it could have many line items. There's also a one-to-one relationship. So one thing can only correlate to one other thing in another table, or a many-to-many relationship, which usually requires some sort of intermediate table to be able to differentiate records there. You usually have one table with the relationship that's many-to-many, and then typically that's shown with like a fork. And then you have an intermediate table and then we have another fork that goes off to this table. So this is a many-to-many relationship, and here you have a primary key, a foreign key, and the other foreign key of the other table. So this is a P. So the foreign key from this table comes over. The foreign key from this table comes over. And that's how you can grab records with the many-to-many relationship. So such as like teachers to students. Multiple teachers can have multiple students, and multiple students can have multiple teachers. So here's how we could show exactly which class each student was in based on that. Well, I want to see the teacher and the student, and then it's probably in this class, because a teacher could teach another class that could have the same student, so it might necessarily not be completely normalized. Here's the SQL Server Designer window. So here we're looking at how a table is being structured. You can see this key up here, which shows that it's a primary key, this invoice ID. You can see the data type of what it is. This looks like it's shown in SQL Server, but Visual Studio also has a similar view. You can see. You can also see the data type and if it allows nulls in that particular field. Common SQL Server data types, you can see all of them pretty well correlate to C#. We have a bit, which is technically like a Boolean. It's a 0 or 1. You have a char, which is a single character, which correlates to C# as well. You have a varchar, which is normally like a string. And the same here. We have date times, which we have in C#. We have decimals, which we have in C# and numerics. big int, which is essentially a regular int, a small int. We have money types in case you only want 2 decimal places. That one's an easy one to just throw in there. And here are tables that make up an MMA Books database, which is a database we'll use in an application later on in the semester. It might be next week's assignment. You can see here, you can see what the primary key is. You can see if it's a one-to-many relationship, so this signifies a one-to-many relationship in this relational database. You can see there's many one-to-many relationships. So states to customers. So a customer is only going to be related to one state, but many states could have, or am I saying that right? So a customer is going to be related to only one state, but multiple states could be tied to a different customer, but they can only be tied to one. So a customer can only ever be tied to one state. Here's our invoice line item table, which shows exactly which products were ordered and how many. You can see that it shows a primary key for each table. Here's the products table and the products table's primary key. And then here are the statements that I'm going to cover in the next video. So we have a select statement, which signifies the R of CRUD, so the ability to read from the database. I only want to select and read items from the database. So here's a select, which I'll cover in the next video. But if you want to, you can come back to this slide. Select name and city from customers, where state is Washington, ordered by name. So you can see you can read it just like English. Here's how to query a single table without needing a join. And then here's some syntax to join 2 tables. So if you're trying to select from multiple tables at one time, you can select all of the columns from both tables from table 1, and then you'll join on your other table. Then you'll want to say how the join criteria is. So you always want to join the primary key with the foreign key of the other table, so it knows what columns to bring back. And I'll cover that in the next video. Here's a example of a join. We're trying to join where this invoice line item ID or invoice ID is 46. That way it can bring back all of the items from that invoice. Here's a syntax to insert into a database. So that's the C of CRUD. We're going to insert into a table, and then we're going to show them what columns we'll be inserting into and what the values are of each column. So for example, we're going to insert into the products table, and we're going to be inserting these columns into the product table in that order, and here are the values that I want you to put into those columns. Here's an update function. So this is the U. So we covered everything but D at the moment. So update a table, in this case products. I want to set the unit price of a product. So again, this should already exist. This record should already exist. I want to set the unit price equals to 54, where the product code equals MCCP. Lastly, the delete, which is the D of CRUD. And the syntax here is pretty simple. Just delete from a table where customer ID is 558. So it's always, I would always recommend doing a select from the table before deleting. That way you know exactly what's being selected. So you could always select star from customers where customer ID equals 558, and then you look at the data and then you say, yep, that's the data I want to delete, and then just simply replace the select star with delete. So that way you're always making sure that the stuff you're deleting is the stuff you want to have deleted. And then here starts to cover data reader and data adapter. I'm going to go ahead and jump into a demonstration in SQL Server.